Hi, my name is Jeff Socek at Felt Bicycles. I'm one of the engineers here. We're having a media day today, so we've been discussing different standardized testing for stiffness and different characteristics of the bike and how they handle and some of the ways we can kind of quantify stiffness and use it for development, basically to communicate with the factories and communicate with different people on how the bikes are going to handle and perform. And one of the tests we were talking about was just a total stiffness test that we do on a lot of the road frames to basically measure the road holding capabilities of the wheels. Basically how parallel the wheels stay to themselves when you're either downhill, out of the saddle, sprinting, etc., etc. And what we have here is just a basic generic test machine that we kind of use. Again, this is something that we don't use for publishing information or data. It's used as an R&D tool, so we can tell one layup from the next layup to the next layup and see if we've accomplished the goals we want of finding the proper balance between total stiffness and rear stiffness or bottom bracket stiffness or diagonal stiffness. The layup is basically how the carbon fiber plies are put down. So with the carbon, the frames are all made out of unidirectional fibers, so we can control how those plies are put down, either 0 degree, 60 degree, 30 degree, 90 degree. And by doing this, we can basically tune the way a bicycle works. So we can put a little more vertical compliance, a little more side-to-side stiffness, maybe we want more torsional rigidity in a frame. We can all do this by tuning the layup of the carbon fiber. And you can test that by obviously riding the bike and seeing how the ride quality is, but then you can also put some numbers to it. And that's kind of what this testing fixture does.